we have started the topic of level of service capacity. Okay, so we looked at the definition of capacity, looked at the definition of level of service. Okay, and why do we need level of service? Okay, so how many levels of service we have? From A to F. Okay, which one is the best? A, always. Right? And F means what? Traffic jam. And E means what? Capacity. Okay, or near capacity. Okay, and we also discussed about capacity in ideal conditions. Okay, which is ideal conditions. I gave you two ideal conditions. One was that all vehicles should be what? What is ideal? All vehicles should be passenger what? All vehicles should be passengers. Passenger cars. Okay, and all drivers should be men. All drivers should be what?
Human.
Elon Musk will disagree with you. He's trying to take the humans out of the car. All drivers must be what? Familiar, regular users. Okay, and even if they are not human, they should be familiar. Seriously. All the research about automated cars is about how to make them familiar with the road. Believe me or not. I should believe me. Okay, so all drivers should be familiar. Okay, these are the ideal conditions, and we said there are three types of uninterrupted flow facilities: freeways, multi-lane highways, two-lane highways, and we are dealing with two of them, which is the freeways and multi-lane highways. Why? Because the procedure is same. In this procedure, what you need is, there are two things which you need. One is the free flow speed, the other one is the speed flow curve. Okay, and I told you this curve is broken into two parts. The first part is a straight line, so the flow changes but the speed remains same, and the value at which or till which it happens, we call it the break point. Okay, and then after the break point, the curve starts and it ends at capacity. Before break point, speed is free flow speed. After break point, speed is this scary value. Okay, and I told you about the parameters in this equation. FFS is free flow speed, C means capacity, DC is critical density, VP is the flow, any value between breakpoint and capacity, and BP is the breakpoint itself. Okay, and then you see parameter A here, which means it's a constant value, and then you can see the parameters in this table for multi-lane highways and freeways. Free flow speed. We can measure free flow speed. I asked you to measure free flow speed for your projects, right? You did which study? Spot speed study. Okay, so that gives you free flow speed. We will also see an equation to calculate free flow speed. So there are two methods for finding out free flow speed. One is do a spot speed study, which you already did. But if you didn't do it, or you could, how do I say? If I'm not your teacher, you are not doing the term project, in that case you can also use an equation as well. Okay? I'm saying this because some of you would do this. They will do the spot speed study and then they will use the equation as well because we have too much free time. Okay? And then they will ask me, doctor, what about the value of this thing and this thing? You don't need to use the equation for free flow speed because you already measured it. Okay? If somebody didn't measure it, he can use the equation. Okay? Then free flow speed for freeways can be adjusted by multiplying it with a speed adjustment factor. We will see about it later on. Okay? So there is free flow speed and there is adjusted free flow speed. Okay, adjusted means take the free flow speed from the first step, multiply with the adjustment factor. What is the adjustment factor? I will show you later on. But only for freeways, multi and highways, free flow speed is as it is. Clear? Okay. Capacity, freeway, this equation, multi and highway, this equation. Okay. These equations have some limits, and the limits are mentioned here. Two things are limited here. One is the value of capacity itself. So the capacity of freeway should not go above 2400. Capacity of multi-lane highway should not go above more than 2300. Okay. And there's a limit of speed as well. The free flow speed of freeway should be between these values. The free flow speed of multi-lane highway should be between these values. Clear? Okay. If the value of capacity is more than the limit of capacity, so you get a value of 2450 for freeway, what will you do? The limit is 2400, right? You got 2450. So what should I do? Use 2400. Okay, you cannot go above the limit. Okay. And for speed, if you are calling it a freeway and the speed is out of this range, there's a problem. There's a problem with your assumption. Okay? You cannot have a freeway and the speed is out of this range. So either you are calling it wrong or your speed is wrong. Got it? Either it's not a freeway or either the speed is not free flow speed. I gave you a limit, right? For the project, what was the limit?
At least
It should at least 70 kilometers per hour. Okay, because if it is less than 70 kilometers per hour, you are going out of these ranges. You don't have freeway. Most of you don't have the freeway. Most of you have the multi-lane highways. Okay, so I give you a common limit. Okay, so it's the same problem here. If you are calling it a multi-lane highway, you are treating it as an uninterrupted flow facility, but the free flow speed is out of this range, you have a problem. Either it's not a multi-lane highway, or either it's not the free flow speed. Clear? Okay. Once you find out the capacity of freeway, you multiply it with capacity adjustment factor, it will become adjusted capacity. Okay. So for freeways, you multiply the adjustment factor with free flow speed, you get adjusted free flow speed. You multiply the adjustment factor with capacity, you get adjusted capacity. For multi-lane highways, no. Free flow speed is as it is, capacity is as it is. Okay. Then we had the break point in the graph, right? What was the break point?
Change in speed.
Yeah, the point from where the speed starts to change. Okay. To calculate the break point of freeways, this equation. Break point of multi-lane highways, this value, no equation. So all multi-lane highways have the same break point, 1400. For freeways, there is an equation. I already explained these parameters. Adjusted free flow speed, capacity adjustment factor. And then there is A, the value of A for freeway and multi-lane highway. Where do we use A? In the curve equation. Okay. This one. Okay. These are some of the curves, speed flow curves for free flow, for freeways which have free flow speeds as mentioned. Okay. So there is a curve when the free flow speed is 55, there is a curve when the free flow speed is 60 and so on. There? Okay. Now you can see, I showed you one curve and these curves, same shape, right? Okay, I showed you the equation and everything, so that's fine. The thing which I want to mention here are the values which you see on the diagonal lines. Okay, so each diagonal line has a value, and the value is, if you look at the units, passenger car per mile. Okay, what value has units of vehicles per mile or passenger cars per mile? Density. So these are values of density, and density is what we use to find out the level of service for freeways and multi-highways. Okay, so each diagonal line is showing density for a specific level of service. I will show you the ranges. Okay, but how do I know that this diagonal line has a density of 11? How do I know this? What does density have to do with this line? Okay, there's a question. So the answer is, density is flow upon speed. Density is flow upon speed. Okay? Just trust me. Okay. So density is flow upon speed. So flow upon speed for this graph is what? It becomes slope, right?
Yeah.
Flow on y-axis, speed on the other axis. If you take density, it becomes slope. Okay? So 11 is basically the slope of this line. 18 is the slope of this line. 26 is the slope of this line. But just keep in mind, slope is vertical upon horizontal, right? So like you have to draw the graph like this. Okay? Or you take the inverse. Yeah. Okay? Slope is what? Vertical upon horizontal, right? Vertical is what? Speed. Horizontal is flow. So if you do speed upon flow, it's inverse of density. It's inverse of density. Okay? So either you rotate the graph and then draw the lines, or take the inverse of density, that becomes a slope. For example, the density for level of service A is 11. So I will take the inverse of 11, it will become the slope of this line. I take the inverse of 18, slope of this line, and these values are fixed. These values are fixed. Clear? Okay. So if I give you any graph and these values are fixed, you can plot these lines yourself. Right or not? You have to do that in the project. Okay? So these values are fixed. So you already know the slopes. The only thing you need is what? The curve. Okay? You get the curve and then you plot these lines according to the slope. Okay? You know where each level of service is. Okay? So this line is for level of service A. This line is for level of service B. If you are in between these lines, level of service B. Here, C, and so on. Clear? And obviously, after capacity you have F. Line or no line, I told you. After that, if you are ahead of the curve, it's F. Same thing for multi-highways. The only difference between the previous graph and this one is, those were for freeways and this one is for multi-highways. Okay? But the lines and the densities, even you see, the values of density are same, 11, 18, 26. Okay? So, I told you that densities are fixed for each level of service, right? Here you can see the values or the range of values for each level of service. So for level of service A, it goes from 0 to 11. For B, more than 11 to 18 and so on. So from here, you got the values. Okay? So for each level of service, I know the density. From density, I get the slope. And I can draw the lines. Okay? And on top of these lines, I will draw my curve. So then I can know where I am. Okay? On my highway, which level of service do I have? Yeah, this is I found somewhere. Okay, it's recorded. I took it from somewhere. Okay, and that person doesn't know that I took it. You can do this, right? It's allowed for education, right or not? Only for B. Okay, don't do this in the exam and say it's for education. Okay, so each level of service has a volume to capacity ratio as well. Capacity is capacity, volume is how much volume you have. So if you take the ratio of these two things, then even without the density and the other calculations, you can define the level of service. Okay, but the point here is when you take the ratio of something, the units must be same. The units must be same. So if you take capacity passenger car per hour per lane, volume should be passenger car per hour per lane. If capacity is flow rate, then you will divide by the flow rate. Got it? V and C, same things. If these are passenger cars, these are passenger cars. If this is per lane, this is per lane. If this is flow rate, this is flow rate. This is volume, then this should also be volume. Clear? Okay. So obviously we said E is when you reach capacity. So volume capacity ratio is 1. More than 1, that means you have F. Okay, and then behind it you have the other levels of service. Okay, so according to this, A is up to 0.3. Okay, so when you reach up to 30% of the capacity, that's 10 level of service A. Okay, this is what we call as service flow rates. The things which you see in the graph, these are called as service flow rates. What are service flow rates? What is the service flow rate? Yeah, tell me. Maximum flow for what? Yes. Okay, maximum flow at each level of service. Okay. So for this highway or this freeway, all of them are for freeways. For a freeway which has a free flow speed of 75, what is the maximum flow rate for A? 820. So from 0 to 820 you have level of service A. When you go beyond 820, level of service will change from A to B until you reach what? 1310. Okay, so after 820 up to this value it is B. Okay, so what is 1310? It is service flow rate for B. Okay, for a highway which has speed 75. Clear? Okay. And how did I get them? From the graph. I showed you these graphs, right? For freeway and so on. Let me show it here. It's bigger. So this line indicates what? Level of service A because of the density, right? This line has slope which is corresponding to the density of A. So wherever this line intersects the curve, that point is my service flow rate for A. Okay. For example, you see the line intersects this curve which has a speed of 55. Okay, and the line is intersecting here. This line is for the density of A. So this point becomes the service flow rate of A. Then this line has a density of B. So this point becomes the service flow rate for B. Clear? Huh? So you have to plot the curve and the lines, and their intersection points will give you the service flow rates. Clear? So we have service flow rates for freeways from the freeway curves, and we have service flow rates for Multilane highways from the Multilane highway curves. Clear or not? Now, to use these curves or to use these values, okay, if I ask you what is the service flow rate for level of service C, tell me from this table, what would be your question to me? Okay, so I tell you my speed is 60. You can tell me the value, right? No problem. Now if I tell you my speed is 62, then can you tell me? We cannot. We don't. We don't. Okay?
So the question is 62.
Yeah, but if the free flow speed is not there, then you make your own curve. That's it. You have to make your own curve. Okay, for the curve, I already showed you. Draw a line up to breakpoint. After breakpoint, draw the curve using this equation. Okay? What was your free flow speed? 86. How much is it in miles per hour? 86 kilometers per hour. How much miles per hour? .86 kilometers. How many miles? 53. Now, do you see a curve of 53 here? No. Okay. So you have to draw your own curve for 53. How do you do that? 53 is your free flow speed. 53 is your free flow speed. Okay. This free flow speed is up to breakpoint. Okay. So if your highway is a Multilane highway, then you will draw a straight line up to the breakpoint, and the breakpoint is 1400. If your highway is a freeway, then you will draw a straight line again up to breakpoint, but the breakpoint is this one. Yeah? Then how do I draw the curve? I know minimum point of the curve is what? The breakpoint. And the maximum point is what? Capacity. I have the equation for capacity, right? So I know the minimum point and I know the maximum point. At the minimum point, at breakpoint, what is my speed? At the breakpoint, what's the speed? Free flow speed. Okay, you guys love zero, right? I can give you zeros, no problem. Okay. So this is the breakpoint, right? The speed is free flow speed. This is capacity. Okay. What's the speed here? Okay. Put Vp equals to capacity and find out the speed. So you have 2 points, right? Minimum point, maximum point. Breakpoint and capacity. You have speed at both of them. Is it enough to draw the curve? Is it enough to draw the curve? 2 points. You already did this in your mind, huh? Right? Is it enough to draw the curve? No. Even if you do this, it's not enough. Okay. So now, from where do I put the? Where do I get the other points? Now, the only thing is I need to know some more values of speed in this range, right? The range between breakpoint and capacity. If I get some more values, I can draw the curve. Okay. So for this range, the equation is this one. Okay. Now you know the range. Minimum is breakpoint, maximum is capacity. Select any value in this range, put it in the equation, and get the value of speed. Okay. For example, your breakpoint is, let's say, 1400. Okay, so this value is 1400. Okay, now let's say my capacity is 2400. Okay, now I need couple of more values between 1400 and 2400, and to put in the equation I will find out the speed and I can plot the curve, right? Okay, so for example, this is just a matter of choice. Okay, for example, I select a value of 1500 and I select a value of 2000. Okay, so I'll find out the speed at 1500, I'll find out the speed at 2000. Now I have 4 points. I can plot the curve, right? Okay, so this is how you plot your own curve. Clear? And why we are plotting the own curve? I already have these. What whom? What? Why are we plotting the curve? Why are we not using these? Free flow speed is not matching. Okay. Okay. So I told you about the adjustment factors, right? For freeways, you have adjustment factor for speed and you have adjustment factor for capacity. Okay. Adjustment factors are required because of 4 reasons. Adjustment factor for freeways are required because of 4 reasons. Weather, incident, driver population, and work zone. Okay. Weather, we know weather, right? Summer. Okay. So weather conditions, cloudy, rainfall, snowfall, okay, and so on. Incident, any accident on the road, okay, some checkpoint on the road, something like this, okay, which is affecting the traffic flow. Driver population, I already discussed earlier. All drivers must be familiar.
Must be familiar.
Familiar. Okay, all drivers must be familiar. Okay, so if they are not familiar, then there is an adjustment factor. And adjustment factor, the 4th reason is work zone. Work zone means construction maintenance activities. Okay, so there are 4 reasons because of which you apply adjustment factors on free flow speed and capacity of freeways. Due to weather conditions, due to driver population, due to incidents, and due to work zone. Okay, from these 4, incident only adjusts the capacity. Incident has no effect on speed, free flow speed. Okay, so there are total 4 reasons. Out of these 4, 3 are common for capacity and free flow speed. The 4th one, incident, only affects capacity. Clear? Okay. Now adjustment factors are applied when you don't meet the ideal conditions. So each one of these reasons has an ideal condition. And I already gave you the ideal condition for driver population, right? Ideal condition of driver population is all drivers are familiar. Not familiar, put the adjustment factor. Clear? Ideal condition for weather, Bahrain. Seriously, right? Seriously. No fog, no rain, bright sunlight. What else do you want? Okay. So Clear, sunny weather, ideal. If not, adjustment factor. Incident is very easy. Incident, no incident. No incident is what? Ideal, right? Incident, apply the adjustment factor. Work zone again, very easy. Work zone, no work zone. What is ideal? No work zone. There, if you have work zone, there's a factor. Okay. Now, if you look at here, I told you there are 4 reasons, right? 4 reasons for adjustment factors. How many adjustment factors you see here? 1. And how many here? 1. So I need to combine those 4 into 1. How do we combine them? We take their product. Product meaning we do what? Multiply. So if you have 3 adjustment factors, multiply all 3 of them. You will get the final value. So CF is the product and SF is the product of all the adjustment factors. Got it? Okay. This is what they're saying. Take it for each reason and multiply them. Okay, now from where do I get the adjustment factors? This table gives you adjustment factor for weather, for capacity. Okay, weather has effect on capacity and free flow speed both. This table gives you the effect on capacity. So what is the weather condition and what does it mean numerically? Okay, so somebody says we had high rain. Okay, very high rain. Okay, why? Because our parking was full of water. Okay, according to us, it's high rain. Somebody comes from Malaysia, he said, oh, I can just fill a bucket here and. So, what does it mean? High rain, not subjectively, in number, what does it mean? Okay, so it's not based upon judgment. Okay, you say high rain, he says medium rain, and so on. No, we have a number for each one. So this table is for free flow speed. Sorry. So there's a misprinting then. So this is for capacity, and yeah, okay, you need the value of free flow speed. Okay, fine. So this is for capacity adjustment. This table is for capacity adjustment of weather. This table is for speed adjustment of weather, SF. Okay. Then we have capacity adjustment for incidents. A table for capacity adjustment for incidents. Okay. So here you need to know how many lanes you have, and you need to know how many lanes are closed because of the incident. Okay, incident I mentioned, a check post, an accident, car broke down, whatever. So no incident is ideal, so the factor is 1. Remember, you are multiplying the factor, right? So ideal value is 1, no change. We have 2 lanes, only the shoulder is closed, this is the factor. One of the 2 lanes is closed, this is the factor. And what is this? Huh? What is this? It means nothing. N for nothing. And A for anything.
No. Applicable.
Not applicable. But why is that so? This was my question. Why I don't have a value here?
Small.
Huh? Look at the number of lanes, you get your answer.
Oh, it's only 2 lanes. How can there be?
You have 2 lanes. 2 lanes blocked. There's nothing now. Road is blocked. No capacity, no factor, no speed. Okay, clear? And obviously 2 lanes, the 3 cannot be blocked. Okay, so the NA values are for those number of lanes which are either not possible or they mean that the entire road is blocked. So 2 out of 2 is blocked, that means the road is blocked, that's it. And 3 out of 2 cannot happen. Okay. So this is for incident, this is for driver population. So driver population affects both speed and capacity, both, right? So this column for capacity, this column for speed. All drivers familiar, ideal condition, factor is 1. Mostly drivers familiar, normal working days, these are the factors. Balanced mix, half from Bahrain, half from Saudi, these are the factors. Mostly unfamiliar, so these are having a holiday here, these are the factors. Got it? So the only thing which is left is the work zone, the factor for work zone. The factor for work zone doesn't have a table, we need to do some calculations. Okay, so there will be some calculation for capacity adjustment factor because of work zone, and some calculation for speed adjustment factor because of the work zone. Okay, this is, we are starting with the capacity adjustment factor because of work zone. Okay, first thing you need to calculate is capacity of the work zone, CWZ. Okay, in this equation we need QDR. QDR stands for Q discharge rate. Q discharge rate. Q discharge rate has another equation. Okay, and then you can also see alpha, which is the reduction in capacity because of the work zone, but alpha has a fixed value which you can see here, 13.4%. Okay, so for capacity of the work zone I need two things, QDR and alpha. QDR, we have an equation, alpha 13.4, clear? Now let us look at the equation of QDR. QDR equation has 1, 2, 3, 4, 5 factors. Okay, the first factor is known as factor of lane closure severity index. Lane closure severity index, FLCSI. FLCSI has this table. Okay, it has an equation as well, which I did not write because we have a table. Okay, we like tables, right? More than the equation. Okay. Again, you need the same things to know which I showed you for the factor of incident. How many lanes you have normally, and how many are open with the work zone. Okay, so when there was no work going on, how many lanes were there? Okay, or before this segment, in some other segment on the same highway where there is no work zone, how many lanes it has? Okay, and with the work zone, how many lanes they are having now? Okay, so 3 and 3, then LCSI is this one, 2 and 2, this one, 4 and 3, this one. So 4 were normal when they started construction work. We are only dealing with now 3 days. So the LCSI will be this one. Okay, so this and this. And what is this column? It's a ratio of these two. Okay, this column is what? Ratio of these two. It's used in the equation. I'm not showing the equation, but just to explain. Open ratio is this upon this. This column upon this column. They already used it, they gave us the values, but just to let you know. If you see an equation for FLCSI, that equation will use this ratio. Clear? So FLCSI from this table. Next factor we have is the factor for barrier type. Okay, so when you have the work zone, for safety purposes, they put some barrier between the work zone and the road. Okay, that barrier can be made of concrete. You see the big concrete barriers, right? On the bridges and so on. Okay, so if the barrier is made up of concrete, then the factor is 0. FBR is 0. For any other material, the factor is 1. Okay, so FBR only has two values, 0 or 1. Concrete 0, others 1. FA, factor for area type. Again, we have only two area types, urban and rural. For urban area, the factor is 0. For rural area, the factor is 1. Okay. Another factor, which is not a factor, is a distance. Distance between the barrier and the edge of the road. Okay, the last or the final boundary of the road. Okay, so how far is it? Clear? So how much is the distance between the barrier and the edge of the road? That is FLAT, lateral distance. Okay, and FDN means factor for day and night. Again, it has only two values, 0 or 1. For daytime it is 0, for night time it is 1. Okay, so you will pick up these factors and you will calculate the capacity of the work zone. Okay, so from these factors you will calculate Q discharge rate. From Q discharge rate you will calculate capacity of the work zone. Okay, after calculating capacity of the work zone, this is how you calculate the adjustment factor of capacity because of work zone. CAWZ is capacity adjustment factor because of work zone, which is capacity of work zone upon normal capacity. Normal capacity these equations. Capacity of the work zone that equation. Okay, clear? You take that ratio, you get the capacity adjustment factor of the work zone. Then for speed adjustment factor of the work zone, I need to calculate the free flow speed of the work zone. This is the equation, that equation. And here again we have 1, 2, 3, 4, 5 and 6 factors. Okay, some of the factors we already know. For example, FSCSI, we know. I showed you the table, right? FBR, factor for barrier. Okay, barrier can be concrete or non-concrete. Factor for day and night. Okay, then there are 3 new factors here. The first one is FSR. FSR is a speed ratio. Speed ratio. Okay, a speed ratio between what? Normal speed limit upon work zone speed limit. So normally when we start the work zone, we reduce the speed, right? We want the driver to go slowly than before. Okay, so this is a ratio between normal speed limit and work zone speed limit. Got it? And SLWZ is the speed limit of the work zone itself. Okay, clear? So FSR is the ratio of normal speed limit and the work zone speed limit. And SLWZ is the work zone speed limit itself. Clear? Huh? Clear? Any questions? Okay, and the only thing left is TRD. TRD stands for total ramp density. We will use it in some other equation afterwards as well, so keep it in mind. Ramp density is number of ramps upon length. Number of ramps upon length. Ramps per mile. But should I count the ramps for the entire highway? No. I'll only count the ramps for a 6-mile length. Okay, 6 mile where my segment is in the middle. My segment is in the middle. Okay, so how many miles I have? 3 forward, 3 backward. Total 6. And my segment is in the middle. Okay, so from my segment I will go 3 miles forward, I'll go 3 miles back. I'll count how many ramps I have. For example, I have 10 ramps. Okay, ramp density is 10 upon 6. 10 number of ramps, 6 is the length. Clear? Okay, so TRD is that value. once you find out the speed limit of the, free flow speed of the work zone, we will divide the free flow speed of the work zone with normal free flow speed. Okay, you'll get the adjustment factor. So adjustment factor is basically the ratio of the factor with the work zone upon normal. So if you are calculating factor of capacity, you need capacity of the work zone upon normal capacity. If you are calculating factor for speed, you need the free flow speed of the work zone upon normal free flow speed. Got it? Clear? Any questions? Okay. So next time we will start with one example related to the factors for work zone. Okay.